Hello everyone, welcome to the class of quantitative methods for management. So guys, now we have reached unit 3.7 and in this class we'll talk about skewness and kurtosis. So before we go further, let's discuss the overview about this topic. So have you ever wondered why some data sets are skewed in one direction while the other follows a perfect normal distribution curve? So basically, to answer this question, we need to understand the shape of the normal distribution curve. While sometime it follows symmetrical pattern, while sometime it follow asymmetrical pattern. So when it comes to asymmetry, when it comes to study of this asymmetry, there we need to understand these two concepts of skewness and kurtosis, which we'll discuss in this present class. Now, discussing the learning objective of this class. So at the end of this topic, you will be able to define the term skewness and kurtosis and explain their significance in statistical analysis. We are going to talk about the relationship between mean median mode in both skewed and symmetrical distribution. We're going to describe the features or characteristics of mesokurtic, leptokurtic, and platykurtic curve in relation with the normal curve. Now, discussing our skewness, skewness basically talks about lack of symmetry. We study skewness to have an idea about the shape of the curve, which we can draw with the help of the given data. Okay, so if in a distribution, if mean, median, mode, or if all are equal to each other, then the distribution is known as a symmetrical distribution. While if you see a kind of asymmetry in the distribution where your mean, median, mode are not equal to each other, then it is a asymmetrical distribution and it is called skewed distribution. And such distribution could either be positively skewed or negatively skewed, as what you can see in the visualization on the screen. Talking about kurtosis, kurtosis basically measures the peakedness or flatness of a distribution curve that help us to understand how a distribution deviate in shape from the standard bell-shaped curve. Okay, as you can see, that the distributions, what you can see a positive kurtosis or negative kurtosis or a normal distribution. So basically, kurtosis help us to understand how a distribution deviates in shape from the standard bell curve. Okay, and in it, when we study kurtosis, it complement the measures like central tendency, dispersion, and skewness, but focuses specifically on the shape of the curve peak. Okay, and it provides insight into extremities of the data and the concentration near the mean. Okay, so when we talk about symmetrical distribution, so in the case of symmetrical distribution, the value of mean, median, mode all coincide. Okay, and that is basically a symmetrical distribution pattern. The spread of the frequencies is same on both sides of the center point of the curve. When we talk about positively skewed distribution, so in a positively skewed distribution, we can say that the value of mean is maximum and that too the mode is minimum, and while the median lies between the mean and mode, where the frequencies are spread out over the greater range of values on the right hand side than the left hand side. That's why it's called positively skewed. When we talk about negatively skewed distribution, the value of mode is maximum and the value of mean is minimum, while the median lies between the two. Okay, here we can say that the frequency is spread out over a greater range of values on the left hand side than the right hand side. Okay, so basically, when we talk about negatively skewed distribution, the frequencies are spread out over a greater range of the values of the left hand side than your value on the right hand side, because of which the mode tends to be maximum while the mean tends to be minimum. When we talk about the mathematical calculation of the skewness that we do through Kyle Pearson coefficient of skewness, where the absolute measure of skewness, basically what we use, the formula is mean minus mode, where it measures the unsuitable for comparing. the skewness in two or more distribution because the unit of the measurement may vary, where the formula for Carl Pearson a coefficient of skewness is mean minus mode by standard deviation. Let's do a numerical where suppose these data sets are given to us like 25, 15, 23, 40, 27, 25, 23, 25, 20, and for this given set of data we need to calculate Carl Pearson coefficient of skewness. Okay, so as you see, there total nine datas are there. So we can find the deviation of these data from their assumed mean. So I assume that the assumed mean as 25. Okay, so then what we did, we found the value of d, where d is equal to x minus your assumed mean, which is 25. So 25 minus 25 is 0, 15 minus 25 minus 10, 23 minus 25 minus 2, 40 minus 25, 15, 27 minus 25, 2, 25 minus 25, 0, 23 minus 25 minus 2, 25 minus 25, 0, 20 minus 25 minus 5. And we did the sum of d, we got the value as 2. And then whatever the d value we got, we just do the square of that. So the sum of d square we got as 362. Okay, and then we can apply the mean formula is assume mean plus summation of d by n. The summation of d we got here is minus 2. So if I do the sum here, minus 10 minus 2 minus 12, minus 12 plus 15 is 3, 3 plus 2 is 5, 5 minus 2 is 3, 3 minus 5 is minus 2. So the sum of d is minus 2 and the sum of d square 362. So here the assume here when we calculate the mean formula is assume mean plus sum of d by n. Assume mean I have assumed as 25. Sum of d is minus 2 and number of data is 9. So if you apply the formula, we got the mean as the 24.78. And then when we find the standard deviation, that is summation of d square by n minus summation of d by n ka whole square. Already we calculated the summation of d square, which is 362, n is 9. Sum of d is minus 2. And when put everything in the formula, we got the sigma as 6.3. A mean we got 24.78 and sigma we got as 6.3 and the mode would be 25 because 25 repeated the maximum in the data. It has a maximum frequency. You can see from the distribution. When you see the distribution here, when you see the distribution, the 25 is repeated three times. So mode is 25. So we got the mean is 24.78. Mode is 25. Sigma is 6.3. So we can apply the formula Carl Pearson coefficient of skewness formula, which is mean minus mode by sigma. So mean was 24.78, mode is 25, sigma is 6.3. So when we calculate, we got the Carl Pearson coefficient of skewness as minus 0.03. Okay, let's do another numerical where we got a kind of uh, discrete data. Okay, where we have in the discrete data we have grouped form of data where we have x values given as 3, 4, 5, 6, 7, 8, 9, 10, and their frequencies, which is talking about the number of time a value is being repeated. So for this data, we can find uh, the deviation from A. Okay, so here what we can do, we took the deviation to find to simplify the calculation. We can directly use summation of fx by summation of f, or we can use d. D is equal to x minus a. Okay, d here is equal to x minus a. Let my assume mean is 6. Okay, so d is equal to x minus 6. Okay, so 3 minus 6 is minus 3. 4 minus 6 is minus 2. 5 minus 6 is minus 1. 6 minus 6 is 0. 7 minus 6 is 1. 8 minus 6 is 2. 9 minus 6 is 3. 10 minus 6 is 4. So I got x is equal to, I got d is equal to x minus 6. So you can correct this deviation from A is equal to d is equal to x minus 6. Just correct this. once you got deviation from A, we can find the square of this data. That would be D square. Then we can multiply F into D. We can multiply F into D square. So the sum of F into D is 480. The sum of F into D square is 1278. Okay, so once we got those values, okay, we can find the mean. Sum of D is 480, N is 355. Assume mean we have taken as 6. So if we solve, we got the mean as 7.35. And then when we applied the same formula, sum of D square by N minus sum of D by N ka whole square, the sum of D square we calculated as 1278. N was 355 and sum of D was 180. So when we applied the formula, the sigma we got as 1.33. Okay, that then from if for seeing the data, we know that the mode is 8 because 8 has repeated the 8 has the maximum frequency. So we got the mode as 8. Okay, we got the mean and we got the standard deviation. Mean is 7.35. The standard deviation is 1.33. So we can apply everything in the formula to get the coefficient of skewness. So coefficient of skewness because 8 is greater than 7.35. So my coefficient of skewness will be negative of minus zero point 0.5. Okay, now the next formula or the next mechanism to calculate coefficient of skewness is Boyle coefficient of skewness. So in Carl Pearson method of measuring skewness, the whole of the series is needed. Okay, in the symmetrical distribution, the quartiles are equidistant from the values of median, and then we can use this measurement because median talks about 50% of data. Quartile 1 talks about 25% of data. Okay. And quartile 3 talks about the 75% data. So I can write median minus Q1 is equal to Q3 minus median. Here you can correct this is Q3 minus median. So the Boyle coefficient of skewness is equal to Q3 plus Q1 minus 2 times of median by Q3 minus Q1. So let's do a numerical based on Boyle coefficient of skewness, where the following data sets are given to us: 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. And for this given data set, we arrange the data set in ascending order, and then we know how to find quartiles, Q1, Q3, median, everything we know. The formula of Q1 is find the n plus 1 by 4th observation. For median, you do n plus 1 by 2 observation. For quartile 3, you do 3 into n plus 1 by 4th observation. So we one by one we can find quartile 1, we got a 6. Okay, then quartile 3 we calculate and we got the quartile 3 as 18. Okay, and then we can similarly find the median. Median is 12. Okay, now the Boyle coefficient skewness would be Q3 plus Q1 minus 2 times of median by Q3 minus Q1. When we'll solve this, okay, we got the value of Boyle coefficient as 0. 18 plus 6 is 24 minus 12 2 is 24. 24 minus 24 is 0 only. Coefficient skewness 0. It means that the given series is symmetrical in nature. Now talking about kurtosis, the kurtosis as an expression is used to describe the peakedness of the curve. Okay, the measure of kurtosis denotes the shape of the top of the frequency curve, where if it very narrow peaked, it is called leptokurtic, while in a symmetrical normal distribution, it is called as mesokurtic, while if it's very much flat, then it's called platykurtic. Then here, when we have a mesokurtic distribution, it is called symmetrical, and it is a standard normal distribution pattern. Okay, for leptokurtic, it is narrow and peaked at the top. For platykurtic, it is flatter than the normal curve. Okay, and here the measure what we use to measure the kurtosis, that is already we have discussed about movements in the previous session. So uh, here the term what we use to measure kurtosis is beta 2. Beta 2 is equal to mu 4 by mu 2 ka whole square. While if beta 2 is equal to 3, then the distribution is said to be normal and the curve is mesokurtic. While if beta 2 is greater than 3, then your distribution is said to be more peaked and the curve is called leptokurtic. While if beta 2 is less than 3, then the distribution is said to be flat topped and curve is platykurtic. Okay, now for the given numerical, we have to calculate beta 1 and beta 2. Okay. Now, mu1, which is if mu1, which is all near to mu1, which is about the mean, okay, which is always zero. When mu2, mu3, mu4, we have discussed, okay, that is sum of FD square by N. Okay, here you got as 500 by 125 is equal to 4. We have discussed that. And we have discussed the same numerical in the movement in the previous session. So we calculated the mu2, mu3, mu4. Okay, when we solve it, we'll get the same value. Okay, and beta 1 is nothing but mu3 whole square by mu2 ka whole cube. Okay, the mu2 was 4, so its cube would be 64. Mu3 was 0, so 0 square would be 0, so b1 is equal to 0, while b2 is equal to mu4 by mu2 ka whole cube, while mu4 was 37.6 and mu2 whole cube is 4 square. So when we calculate, we got the beta 2 is equal to 2.35. If you are facing difficulty in understanding how we got sum of FD square, sum of FD cube, sum of FD to the power 4, okay, how we got this value mu1, mu2, mu3, mu4, you can go through the video of Kurtosis. There we have discussed the same numerical. So we are just using the data from the same numerical here. So since the value V2 is less than 3, hence the curve is platykurtic. So guys, in this session, we have discussed about skewness and how skewness help us in measuring asymmetry in the data. We have discussed about that. When we talk about symmetrical distribution, it has mean is equal to median is equal to mode, while in positively skewed distribution, we have mean greater than median, then greater than mode. While in negatively skewed distribution, we have mode greater than median, then mean. Okay, the contestant basically measures the peakedness of the curve. In the normal curve, that is called mesokurtic, while leptokurtic is narrow or peaked, very much narrow peaked curve, while platykurtic is very much flattened curve. So I hope you have understood what we have done in this session. So it's time to wind up this session. Thank you everyone. I'll see you all in next class. Bye everyone.